Hello and welcome to video lecture number 7, which covers section 0.6, Algebra 1 Review, Solving Equations by Undoing. As always, please take a moment to read today's objective. As the objective states, your goal for today is to be able to solve equations, and to do that, you need to know what an equation is. That takes us to our first definition of an equation. An equation is a mathematical statement with an equal sign. So it can be anything at all provided that sign is there. If it's not, we call that an expression. So I've provided 3 examples of equations. The first one is from science. You may be familiar with this one. E equals mc squared, arguably the most famous equation of all. We have a geometry equation. The area of a circle is area equals pi r squared. And then I just threw in another equation, y equals x. So take a look at those, and if you have questions, please ask tomorrow in class. The next definition then is solving an equation, and the word solve is thrown around a lot in math, and a lot of times it's actually misused. So solving an equation refers to the process of isolating the variable to find its numerical value or values. Sometimes you'll have more than one answer to an equation, sometimes you won't have any answers at all, or sometimes you could have infinitely many solutions. So all 3 cases can arise. However, just make sure that you understand that solving refers to getting that variable alone. So by isolating, I mean alone. The variable needs to be all by itself, and then you are done solving. I've created a little guide here for you that will give you a step-by-step breakdown on how you should begin solving equations when we're undoing. So combining like terms that are on the same side of the equal sign is the first thing I'd always like you to check for when solving equations. So if you take a look at this, I will divide each side of the equal sign with this vertical bar. You do not have to do that, but that makes it a little more clear for me. So I'm going to combine whatever I can on each individual side first. I'm not going to move anything around from one side to the other yet. So if you remember from yesterday, combining like terms, 2x minus 4x, we're only going to deal with the coefficient, so that would give us negative 2x. Then I'm going to look strictly to the right side, and notice we actually have a distributive property case here first. This would be 4x plus 12, and then the minus 2x. Well, I still have to combine the 4x and the negative 2x on the right side, so that will give me 2x once again. And so at this point, I've combined everything I possibly could on the left and everything I could on the right. Let's go to step 2. Step 2 now asks us to actually combine everything, whether it's on the same side or not. Now we've already done the same side combining. Now we need to combine things even if they are on opposite sides. So notice that the negative 2x and the 2x are like terms, but they are on opposite sides of the equal sign. So we need to move them. In order to do so, we're going to have to do the opposite of whatever that sign is. So if I want to move 2x over to the left, I must subtract 2x. That will cancel it out and get rid of it. Well, as long as I do that to the other side, I've created balance, and I can move that over to combine it. So now, when I combine the left side, I have negative 2 minus 2, and that's simply negative 4. So we have negative 4x equals 12, and now all of the like terms have been combined. We will now go to step 3. Step 3 asks us to isolate the variable term, and in this case, notice negative 4x is isolated. It is all by itself, so step 3 is kind of already done. The final step, step 4, asks us to undo. So the final part we need to complete here is to get that x all alone. We do not want negative 4x, we want just the x. So notice, you need to ask yourself, in this case, negative 4x, what is this operation between them? Well, if you said multiplication, you're correct. Well, how do you undo multiplication? I've given you a little guide here, and multiplication is undone by division. So for us to finally solve this equation, we would take the negative 4x equals 12, and because the negative 4 and x are being multiplied, we would divide both sides by the negative 4. That will undo the negative 4 times, and notice x is now by itself. Once you calculate 12 divided by negative 4, you'll get negative 3, and notice our final answer. We have solved it because x, the variable, is completely by itself. There's no negatives, no other numbers, nothing by it. It is completely alone. In this case, there is only one answer, and that answer is negative 3. The directions for example 1 then are pretty straightforward. It asks us to solve each one of these equations for the indicated variable, and of course, please show your work. So I'll pick a few of these to do with you, and then I ask that you try the rest on your own before you get to class, and you can check them tomorrow. So I'll start with letter D. So notice the first thing I would like to do here is combine this negative 4 and the 6. They are like terms on opposite sides. There are no like terms on the same side that I combine, so I'm going to want to move that 4 to the other side. It is a negative 4, so I will add 4 to both sides. After adding 4 to both sides, we end up with the equation 2/5 x equals 10. And notice 2x over 5 is the same thing as 2/5 x, and we can talk about why that is tomorrow if you have questions. Well, at this point, the only thing left to do is to get rid of the 2/5, the coefficient in front of x. Now remember, what's being done between them is multiplication. So to undo multiplication, I can divide. However, we're dealing with a fraction. So instead of dividing by 2/5, remember, another way to get rid of a fraction is simply to multiply by its reciprocal. So an easy way to get rid of the 2/5 is to multiply by 5/2. And remember, multiplying straight across these two fractions would give us 10 over 10. 10 over 10 is simply 1, and that would give us 1x, or x completely alone, and that's what we want. However, you must multiply the other side by that 5/2 as well. When you do that, you go straight across, and you will get 50 over 2. Well, simplifying 50 over 2 gives us 25. So your final answer to letter D would be x equals 25. A way to check your answer, and something I always recommend doing, is once you get it, plug it back in. If you plug it back in for x and simplify, will you get 6? You should. So you can always check that to make sure your answer is correct. The next example I'll show you is letter F. The first thing I've done is I've distributed the 3 to the 6r and the negative 8 inside parentheses. The result of that I will circle here now and is 18r minus 24. So after I do the distributive property, I just copy the rest of the problem down on the next line, and now I have 30 plus 2r equals 2r plus 18r minus 24. The next thing that we're going to do is look for like terms on either side of the equal sign. If you notice, on the right side, 2r and 18r are like terms, so I'm going to combine them by adding them together and just adding their coefficients. 2 plus 18 is 20, so now we have 20r. At this point, there are no like terms to be combined on either side. All of our like terms are now on opposite sides of the equal sign, so we'll work to combine them. The 2r and the 20r on either side are like terms, and to combine these, I can't just add them and get 22r. I need to move either the 20r to the left or the 2r to the right, and it really is your choice. Now, I'm going to choose to subtract 2r, because that will leave me with positive values instead of negatives. So that cancels out the positive 2r on the left, and then 20 minus 2 is 18. So now we have 30 equals 18r minus 24. Do you know where to go from here? We still have some combining to do, and the 24 negative and the 30 are our like terms here. So how do I combine them? Well, you could move the 30 to the right, or you could move the negative 24 over to the left. I'm going to choose to add the 24 over so I can maintain at least some value on both sides. If you don't, you'll leave 0 on one side, and I always recommend to avoid doing that if possible. So now what we have as a result is 54 equals 18r. There is only one more move to make in this problem, and it's to undo that 18 in front of the r. Remember, 18r is a symbol of multiplication. To undo that, we're going to divide by 18 on both sides. Remember, I don't want to subtract 18r because that would move r with it. I want to leave r alone. So the only way to do that is get rid of just the 18, and to do so you divide. Well, 54 divided by 18 is 3. So in this case, our final answer is r equals 3. Once again, one solution to this equation, and if you were to plug it in everywhere you saw an r in the original, and you simplified the left side and the right side, those two numbers would have to be equal. The last example I'll show you is letter J. Now, if you look, this is a special type of an equation known as a proportion. And to start these problems, you're going to cross multiply. And if you don't know what that is, I'll show you here now. Please be sure that you're not going to go straight across to multiply these. These are not two fractions that are being divided or being added or subtracted or multiplied. There is an equal sign in between them. So please do not find a common denominator or multiply straight across or even flip one of these equations. We're trying to solve. And remember, we're trying to solve for that variable right there. So I mentioned cross multiplication. What that means is you're going to take the top of one fraction and multiply it by the bottom of another, and you're going to have to do that with both. So as a result, when I multiply 12 and m, I get 12m. The equal sign has to remain between these two expressions, and then we have 3 times negative 16. From here, we will multiply the 3 and the negative 16 to give us negative 48. At this stage, we now have 12m equals negative 48. Do you know what to do from here? The last move would be to divide both sides by 12 to get m alone. Upon doing that, you will arrive at a final answer of m equals negative 4. Once again, one single answer to the equation, and if you check it and plug it in, the statement would read 3/12 equals negative 4 over negative 16. Is that a true statement? Well, think about the percentages. 3/12 is 1/4 or 25%, and 4 over 16 is also 1/4 or 25%. So indeed, negative 4 is our correct answer. So this concludes video lecture number 7. Please take a moment to look over your notes and the examples you've tried and come up with at least one question you still have from this lesson that you can bring to your group for tomorrow. Good luck.